Welcome to Math Zara.
In today's video, we will be solving radical equations. Now, a radical equation has a variable under a square root or an nth root. We need to isolate the section that actually has our root. We could start by adding 18 to both sides of this equation, which gives us the square root of 7x plus 15. The 18s will cancel, and negative 12 plus 18 is a positive 6. Now, we need to get rid of our square root. So we know that the square root of x squared equals just x. The square root will cancel our square out. So we go ahead and we square both sides of this equation. Now the square root is cancelled out, and that leaves us with 7x plus 15, and 6 squared would be 36. Now we have a simple linear equation, just 2 steps. We subtract 15 from both sides, and we're left with 7x and 36 minus 15, that's 21. Then we could go and divide both sides of our equation by 7, and we're left with just positive 3. Because of the nature of this equation, we know we cannot take the square root of a negative number, which will give us a complex or imaginary number. So we need to check our answer to see if this solution actually holds. So we're checking for extraneous solutions. We will check if x is actually equal to 3. Now, the square root of 7x, which is 3, plus 15 minus 18 equals negative 12. Now, we notice that we'll have a positive under a square root. 7 times 3, that's 21, plus 15, minus 18 equals negative 12. The square root of 36 minus 18 equals negative 12. And of course, the square root of 36 is positive 6. Now, we know that the square root of a number is positive or negative, but we're taking the principal root in this case, which is a positive value. And of course, 6 minus 12 is indeed negative 12. So this holds. And that brings us to the end of question 1. Now let's take a look at number 2. Now we have the square root of 21 minus 5x equals x minus 3. Again, we will start by squaring both sides of this equation. So the square root of 21 minus 5x all squared equals x minus 3 all squared. Now the square root is cancelled by the square. We're left with 21 minus 5x. And on the right side, we're squaring this binomial. So we write it as x minus 3 times x minus 3. The left side stays, and we will FOIL the right side, which means we'll have x times x, which will be x squared, x times negative 3, negative 3x, negative 3 times x, and negative 3 times negative 3 gives us a positive 9. From here, we will simplify by grouping the like terms. We could start by adding 5x to both sides, which would leave us with a 21 on the left side, x squared, negative 6x, which would be negative 3x minus 3x. Now we add the 5x to both sides, which gives us a positive 5x plus 9. So we basically just move this negative 5x to our right side, and we just added it. Let's simplify a little bit further. X squared minus 6x plus 5x, that's negative x, plus 9. Then we could subtract 21 from both sides. that will be 0 equals x squared minus x, and 9 minus 21, that gives us negative 12. Now we need to factor our quadratic. So we need two numbers that would multiply to negative 12, and we would add to a negative 1, since the coefficient of the b term is negative 1, negative 1x. So we need two factors that are just 1 unit apart. So those two factors of 12, or negative 12, would be 4 and 3. Now we need a negative 1, so our larger factor needs to be negative, which leads us to x minus 4 and x plus 3 equals 0. Let us apply this 0 property that says x minus 4 equals 0, or x plus 3 equals 0. We add 4 to both sides, and we subtract 3 from both sides. Now, similarly, we need to check our answers as we did in the previous question. Now, our equation, let's take a look at it again. Let's copy it. Let's put it down here. And we will check this for extraneous solutions. We will start with x being equal to positive 4. So we will substitute this to see if the equation actually makes sense. So we have the square root of 21 minus 5 times 4, and that's 4 minus 3. Now that's 21 minus 20, that's just 1. And 4 minus 3, that's just 1. And the principal square root, which is the positive square root of 1, is indeed 1. So this checks out, which is true. Let's take a look at, say, when x equals negative 3. We have the square root of 21 minus 5 times negative 3 equals negative 3 minus 3. No, that's 21. Negative 5 times negative 3 gives us a positive 15. And minus 3 is a minus 6. Now 21 plus 15, that's positive 36. Now the square root of 36 is positive 6. And we know that positive 6 is not equal to negative 6, which means we need to discard this solution, which means our only solution is x equals 4.